This video is brought to you by Streamlit. More on them in a little. Today we're going to build an interactive dashboard like one that you could share in your portfolio for prospective employers. Rather than just going through the tutorial on its own, I'm going to explain how I would approach the problem and highlight the things that employers will be looking for in your work, or what they might be looking for. The data we're going to be using is from my own YouTube channel, but you could do this with any social data that you have access to. I think that this is a particularly good use case because I can act as the stakeholder and walk you through what I would personally be looking for in an analysis like this. When doing projects, it's really important to think about who the end user is. How are they hoping to grow their business and what metrics might be relevant to them? If possible, you want to talk with them about their pain points and what information they would like to have. This is especially true for an interactive product like a dashboard. The success of dashboards or other digital products is evaluated by the business value and the impact that they can drive. This is even more important than the aesthetics or even the elegance of the analysis. This is something that we want to constantly keep in mind as we build this out. We'll be using Python, Plotly, and Streamlit to build this dashboard. I'm especially excited to say that Streamlit is sponsoring this video. I've been using Streamlit and sharing about it for the past few years for free, and it's incredible now that we can do this in a more formal fashion. They're launching a great initiative called the 30 Days of Streamlit, very similar to my 66 Days of Data that I highly encourage you to participate in. So help you improve your dashboarding skills, help you build out your portfolio, a lot of incredible benefits. More details on that in the description of the video. When approaching an analysis, it's important to think about why you're doing it in the first place. If it's for work, it's generally to drive the value of the business. In this case, we're using my YouTube data, so we should start thinking about how this could be useful to my channel. What types of things might a YouTuber be interested in learning from the data? Let's brainstorm a few things first. So the first thing that comes to mind for me is they're probably interested in growing their channel. That's something that's relevant for me as well. Looking at what videos help to grow the channel the most would probably be a pretty good starting place. YouTubers are also probably looking to understand new video ideas. Understanding what people are looking for could also be useful. Finally, they might also want to keep up to date with how their new videos are performing against a baseline to see where they should tweak things. If their YouTube content is for profit, they might also want to understand something about which topics earn the most income. While this isn't an important metric for me, if you're showcasing something like this to the business where profit is a key metric, you likely want to include that as well. Today, we're not going to build all these into the dashboard. There's a lot of room for you to expand on this and improve on this, but this is how I'd go about thinking about framing a dashboard analysis and starting the building process. Now let's get our hands dirty with some data. All right, everyone, before we get started, I just wanted to show you what the final dashboard will look like. It isn't too fancy. Again, this is something you can really spice up. This is just setting the groundwork for you to be able to build on it. So what I start with is the overall channel aggregated health. So I'm looking at the performance in the last 6 months versus a baseline. You can also on this page see how all of the individual videos perform against the baseline as well. And I'll talk about how I build the baseline and all those types of things too. The second thing is you can see the individual video analysis. So we can say maybe how did this video perform? And you can see that it performed below average, I guess. But we can see how many people watched a video who were subscribed versus not subscribed, and the breakup by the largest audiences that I have. It's also pretty cool to see the comparison of the video over time, as I alluded to before. We can see the 80th percentile, the 50th percentile, and the 20th percentile, and this red line is how the current video performed over the first 30 days, which is usually how I evaluate if a video is going to be successful. I think it's really important to note also just how many tabs and things I have open. This is about half the tabs that I used, and there's a mix of Stack Overflow, NumPy, Pandas, a lot of Plotly and those types of things. And that's just to say that an individual project, right, it's not super straightforward. It's iterative. We have to Google a lot. We have to figure these things out a lot as we go. No one just sits down and codes something up in one sitting. That would be completely ridiculous. So I will tell you as I go along the areas where I struggled and where I looked for some additional help from Google. I obviously didn't include everything because this would have been like a 4 or 5 hour tutorial if I did. But I think it is important, again, to emphasize that this is a process that iterates and changes over time. So with that being said, let's jump into it. Okay, so the first thing I recommend that everyone do is to create a clean environment for us to do this project in. This is something I do for all my projects. It helps me organize what packages I'm working with, what versions I'm using, and just makes things overall easy. It also helps when we're actually putting this dashboard into production on GitHub. We have to have the specific versions of all the libraries that we're going to be using saved. So this helps us do that really easily. So what we're going to do is we're going to open up Anaconda and the Anaconda prompt. This is something I highly recommend using. I have a video that I will link about how to configure Anaconda as well. But Anaconda is just basically a way that you can encapsulate all of your Python and all of the different libraries and versions into a nice simple place. So what we're gonna do is we're gonna just change folders. So I'm gonna go into my documents. And then I think I made a YouTube dashboard Streamlit folder. So I'm gonna conda create new, and we're gonna do Python, and then we're gonna name this YouTube dashboard Streamlit, and then we're going to use Python equals 3.8. So this is just going to create our environment, pretty straightforward, and we're going to open this environment and do everything in here. So I'm using just the Windows conda environment here. You can do this on Linux, you can do it on any other type of computer as well. So this is just going to install the base packages for the conda environment. What's going to be most relevant here is pip, so we're going to use pip to install pretty much everything else. All right, so now we are going to zoom in a little bit more. We are going to conda activate the environment we just created. So UT, it looks like I spelled it wrong, but that's okay. I forgot the D. These things happen. So now we're in our environment. We want to install a couple of things. So we need to have Streamlit. So we're going to pip install Streamlit. We're also going to install Plotly, and that should be everything that we need. So again, this will be pretty quick, but this will help you set up the exact environment that you need. You can also just take the requirements file that I create in the GitHub repo and use that to create a new environment. I should probably also make a YAML file that will allow you to do that directly in conda, but we'll see if I get around to it. Okay, so after you install Streamlit, you can do Streamlit and then check the version, and it shows that it's installed. Now we also want to pip install Plotly. That's the main visualization software that we're going to be using here. Okay, now that that's installed, we're going to install one last thing, or I'm going to, you don't have to. I like to use Spider for my Python development. You can use Jupyter, you can use VS Code, you can use a bunch of different IDEs. For Jupyter, at least for me, it's easier. It's, it works in a Jupyter environment, so it's not as easy to write just straight Python code. I find that Spider lets me write regular Python code rather than having to write it in cells and run that relatively easily. So this is my preferred method. Again, you can use whatever you want here. Okay, excellent. So now we can fire up Spider. All right, while that's loading, let's go find our data. So you can go onto Kaggle. I will put the link below, and you can download all of this information here. Also, if you do a cool analysis, there have been some really awesome ones so far. Big shout out to a bunch of these. You can upload it here as well. So we click download, it downloads here. We're gonna load this into the correct file location. So for me, it's gonna be in my documents. And I created this YouTube dashboard, so we can open this up. And I'll just drag and drop those in to, where the heck did I put that file? And yes, I will, as you can see, just drag these in. You can do this in the command line if you really want to, but this should work perfectly fine. Now let's open up Spider. So this is what the IDE looks like for me. What we're gonna first wanna do here is go in and open up that file directory that we just described. So this is YouTube dashboard, and we can check what files are in it. So we do have the relevant files. So one thing that I have done, and as I had mentioned, as I have this file for organizing everything, we want to make sure we save this into the correct file location. So we're going to put this into the YouTube dashboard Streamlit. And now we can get started. So the first thing we want to do is load in all of the relevant libraries. Rather than typing this out, I'm just going to copy and paste. This is just going to be a little bit easier for everyone. Save you some time, save me some time. So the first thing we're going to include is pandas. That's how we're going to be doing all of our data manipulation. Next, we're going to use NumPy. NumPy, I actually don't really remember if I use it explicitly, but it's always good to have. It helps you work with different types of arrays, different data structures within data science. We're going to include Plotly graph objects, which is a version of Plotly that is highly customizable. It allows you to isolate and to adjust almost any aspect of the Plotly graphs. We're also going to use, excuse me. We're also going to include Plotly Express, which is a little bit more user-friendly. It works with your data set. It makes some assumptions of the data. So we can't always make it exactly how we want, but it is, again, a lot easier to use for beginners. Next, we're going to import Streamlit, which is how we're hosting our dashboard. And finally, we're including datetime. So I'll highlight this, press Shift-Enter, and that will load everything in. We're not going to define any functions yet, but let's also load in some of our data. So we have 4 different data sets that we're going to include. So that's going to be dfag, which is just the aggregated data that has all of the, over the 220 some odd videos that I had to this point, everything that was relevant. Let's just load this in really quickly so I can explain something. So if we see here, the first column is the total, and we don't want that. That'll mess up all of our results if we're trying to take the aggregate or the median or any of these types of things. So what I did here is I used the integer location, and what we did with that is we just skipped the first row and included everything else. So this is which rows you want, this is which columns you want, and for me this was the easiest way to do that. So now if we reload it again, we can see that the total row has been removed. So that's all pretty easy. I also wanted to get some additional data, which is this dfag sub. So this is the same aggregated data, but we include information on if the individuals who watched the video were subscribers or not, and also what country those views came from. Next, we have the comment data and the time series data. Now, these, to be perfectly honest, I didn't really use the comment data, but I do use the time series data, and it'll be nice to include the comment data if you want to do some additional analysis here, which I highly recommend doing, right? So we can include these two, and that isn't necessarily everything. In this step, I thought it would be relevant to do just a little bit of feature engineering. So let's talk about those. I know I probably should put this in engineered data, but you'll see why I did it here in a second. So there's a couple things that I did with the aggregated data, and let me just copy and paste those and walk through them. So the first thing is I renamed all of the columns. There weren't that many columns. There were like 19, so I thought I could just go and do it by hand. That worked out perfectly fine. The reason I did that is for some reason, when I loaded it in, the columns had some weird ASCII values. So when I would actually type them correctly, it wouldn't match up. It wouldn't let me select the specific columns. So I just went through and renamed them. You can do this in a more systematic way, but for me, honestly, it was a little quicker just to do it this way. I also could have imported some ASCII libraries and corrected things that way. But since it was only with this aggregated data set, I decided to just rename the columns and be done with it. You can fool around with different ways to do this, but again, this is like a little constraint, a little like impurity in the data that you're seeing with a lot of data science projects. Next, what I wanted to make sure I did was look at the video publish time. So in the current data set, the publish time is in a string, or it's just like an object. If we want to make it most useful to us, we convert it to a date time value. So date time values mean that we can take the publish time and we can turn it into, we can sort by that. We can get a date difference from that if we wanted to see how far the date was from something else. So this is going to make that time field a lot more useful and relevant to our analysis. I also did something very similar with average view duration. So this was just like a string timestamp, and we converted it using, again, date time into like a time field. So it's hours, minutes, and seconds based on the video. And with that new time field, we were able to calculate how many seconds the average view duration is. So this is a lot more useful to us than just this text string of information about the amount of time each video is watched. It actually tells us the seconds, and with seconds being a continuous variable, it is significantly more useful to us. The next two were just some other cool data points and cool new features that I thought would be relevant. So engagement ratio, we just take all the different types of engagement and divide it by the views. Same with the views and sub gained. We take the number of views and divide it by the subscribers gained for that video. What I found is that these were actually just terrible metrics and didn't tell me anything, aside from that when I had really popular videos that were viewed a lot, the ratios were really low. So this was more of a, it didn't really tell me anything new. It just told me that, when a video is really popular, there's just generally going to be less engagement, which doesn't, I don't think, help me in any way, shape, or form. But again, that's part of data science, where you're learning these things and you see that you create some features and they're great and some features aren't great. The last engineering we really did was taking date time, and I didn't copy that in yet, but what we're going to do here is very similar to what we did with the other time fields. We just need to make sure that it is not a string and it is put into date time. And Pandas has built-in date time. This date time that we use up here is used just a little bit differently. They can be used interchangeably for the most part, but it's hard, at least for me conceptually, to use the Pandas date time when I'm putting it in a Lambda function or something like that. All right, so if you're not familiar with a Lambda function, let me just explain what that is really quickly. This is something I use very frequently for some light feature engineering. And probably the best way to do that is for us to just load in these, like the first couple rows of data, and compare what average view duration looks like before and after we do the engineering on it. So right here we can see it looks like this sort of text field with hour, minute, second. This is just an object. It is not a date time object. So when we use a Lambda function, we apply, well, what apply does is it applies whatever function you pass it to every single row or entry in this series. So whatever function we're applying, we'd apply it to that one, and then that one, and then that one. Now, the Lambda function lets us just define our function right here. So we have Lambda x, and the function is applied on x. So we just take the date time, and we strip time, and then we convert the date time into this format. So now, after we run this, we can see that the average view duration now is in this date time format that I've described. Hopefully you can watch this in HD and see what that actually looks like. I apologize if it's a little bit small. All right, now let's keep going with the rest of our analysis here. So we're gonna load all these things in. And the first thing we wanna do is that we wanna create essentially a function that reads in this data. This is gonna make it a lot easier for us to work with this in Streamlit. So we're gonna just call this load data. I'm gonna lowercase that, load data. We're gonna just put all of this into a function. And then what we're gonna return is just the data sets that we created. So we're gonna return df ag sub, df comments, and df time. Great. And so now if we want to load this data in more consistently, we just set that equal to load data, right? So we're defining these here, but they're defined in the function, so they're not defined globally. Now, every time we want to load all the data, we just run this function and it goes through all of this. Streamlit has this great, I guess, like system in place where you can cache the data, so you only have to load it in once, and it doesn't load every single time you reload the page. And in order to do that, we just use this. And so now, if we wanted to run the dashboard and have it update, it would work perfectly fine for that. So let's save this and let's jump around a little bit to just structuring our dashboard and figuring out just a tiny bit about what it would look like. So in order to run our dashboard, in order to pop it up, let's open up a new Anaconda prompt. All right, and so let's make that a little bit bigger. And then we're still gonna go into our other environment. We have to change our directory as well. So we'll go to Documents and we'll go to YouTube Dashboard Streamlit. And then we're going to Streamlit run ken dashboard.py. Okay. So when we run this, we'll get to see what the base Streamlit dashboard looks like. And I will just drag and drop. This should pop up automatically, or you can copy and paste the localhost information there. So as you can see, this is a completely blank dashboard. There is nothing in it. Now, why don't we just add some quick elements to that? So the first thing we want to add, for me, is a sidebar. So a sidebar will help us navigate. As you saw in the previous iteration, what I used the sidebar for was to separate the total picture of the video and the individual video data performance, right? So let's just really quickly add that in. The line of code is going to be fairly straightforward here. It is just going to be this. So we're going to add in a sidebar, and you can get all this information on the Streamlit documentation. They have really good documentation about what all these things are, but we're just going to, it's Streamlit, we're adding a sidebar, and then we're adding a select box. This is what the statement is going to be, aggregate or individual video. And then the two options are going to be aggregate metrics and individual video analysis, right? So let's just save that and then go back to our Streamlit dashboard. So now I always click always rerun. Now we can just choose between these two. So we added a button, really cool to be able to do that. So as we build our dashboard out, we want to be thinking about the two different types of features that we have, aggregate metrics and individual video analysis. We're going to start again with this aggregate metrics and hopefully build some pretty cool and useful stuff. Okay, let's take a quick look at the actual dashboard. So we want to get the median metrics over time for the channel. And, you know, we also want to compare that against a baseline. And for these little percentage things, we're going to want to create the deltas from what currently is the median for the last 6 months versus the last 12 months. So let's do a little feature engineering to try to figure that out. So right here, oops. So let's first just get the aggregated differential for all of the data. So we're going to do df_ag_diff, and that's going to equal df_ag.copy. So when we create a copy, it doesn't mess up any of the things in df_ag. It's just sort of a good practice to do it this way. Next, we want to make sure that the data is from this most recent 12 months. It isn't useful, in my opinion, to look at the medians of the data or the differential of the data from the entire history of the channel, because a lot of the videos I put out earlier don't really have much viewership. So what we're going to do here is we're going to take like a 12-month time window, and we're going to figure out what was the date 12 months before the previous, the most recent video was published. So we're going to take video publish time max. So if we look at this, let's just run this to make this copy. And if we look at this, we can see when the most recent date was published. So this data isn't like exactly new, but we can see the most recent video I published was January 17th, right? So we'll take that. And then what this is going to do here is we're going to take 12 months minus that and get a number. So let's just run that. And then you can see what this number equates to. So this number here is exactly 1 year previous to that. So that's what we're going to be basing our median off of. Now, what we want to do is get the median for all of the values in this data frame. So something that might be useful for us to do is actually just look at all of the data here and see what columns there are. So we have the publish time, we have, comments added. Let's sort by publish time. Shares, dislikes, likes, subscribers lost, subscribers gained, RPM, CPM, average percentage viewed, views. Let's see what this is. I think this is watch time in seconds. I'm not great at clicking at things. But as you can see, there's a lot of continuous variables. What we want to do is just get the median for all of these and only include those. So we're going to create this median aggregate that's just going to get the median for every single column. And so what we want to do is we want to take only the last 12 months. So we're going to filter the data frame for only dates that are greater than January 17th, 2021. And we're going to take the median of all of those. So if we run that, let's see what it looks like. So here is what all of the medians look like for all of the continuous fields. When we use median, we automatically filter out only the integers and the float values. Now, if we wanted to do that more organically, like just get the numeric columns, we could run something like this, where this just gives true false of which columns which columns are continuous, floats, or ints, and other. So we can take the NumPy array, and then we look at the data types, and if they're equal to float, or this means or in computer language, or if they're an int, then we'll include them as true. Otherwise, they'll be false. So let's just look at what that looks like. So if we run numeric columns, we'll just get this giant list of trues and falses. And we can feed that specific list right into our data frame. So if we use the location, I guess you can use integer location for this, we'll be able to get the specific numeric columns. So for this, we can set the value of the numeric columns equal to the value of the numeric columns minus the median divided by the median aggregate. So what this is going to do is just going to look at the percent difference from those. And this is going to be useful for analyzing all of our data here. Let's run that. It's going to be what we use to calculate all of these different values here. The metrics at the top we do last, but these are the ones which took me the most time to figure out in general. Okay, so what we just built will allow us to create this data frame here that is, again, really useful to me. I can see each individual video and how it performed across all of the major categories that are relevant to me. Before we do that, let's go ahead and build out all of these metrics. So metrics are a really unique and cool component of Streamlit dashboards. You can have these at the top, and you also can incorporate a delta. So in this case, the delta shows the percent change in all of these aggregate metrics that are relevant for the last 6 months compared to the last year of performance. So let's go ahead and dive into some of the Streamlit aspects here. What we're first going to do is we're going to show you how to make it so that these aggregate metrics and the individual video analysis, they show just different things when you toggle them on and off. So let's go ahead and do that really quickly. So the first thing we're going to do is we're going to say if add sidebar is equal to aggregate. Let's just copy this so I don't botch the spelling. Oops. All right, so if it's equal to that, then we'll just return something. So this is how you just write to the page in Streamlit. Let's just say aggregate. We'll just say ag. And then if we say if And then we'll just do for the second one, if add sidebar equals these individual video analysis. Like that. We'll write Indo. Okay, so if we save that, we should see on our Streamlit page, we have ind for individual and ag for aggregate. So in those if statements, we can just write whatever we want. We can put the graphs of whatever we want. And as long as that specific metric is selected here, or that variable is selected here, we can change it will, which is really cool. It just makes it so that you can switch through whatever is being shown on your dashboard very, very easily. So now let's do that first one with the components here. So instead of having this ag here, we're going to start putting in some metrics. So we're actually going to do a little bit more data engineering. I'm just going to copy and paste it and walk through it. It's going to just be a lot more efficient if I do it that way. So what I'm going to do here is select the specific metrics that I want to show up top. Rather than showing all of the metrics, which would take up a ton of space, I figured this was a lot easier. So we're choosing, how many metrics was it? 1, 2, 3, 4, 5, 10 different metrics, which are video publish time. Well, we're actually not going to be including video publish time. That's just for us to get the differential. But we're going to have views, likes, subscribers, shares, comments added, RPM, which is how much money you make per 1,000 views, average percentage views, average view duration in seconds, engagement ratio, and views versus subs gained. So these are all of the metrics that I find most relevant, basically in descending order. So views is the most important to me, likes, subscribers, shares, comments. As you can tell, these are all either watching or engagement. And I think those are directly correlated with channel growth and people actually enjoying the videos that I'm putting out. So the next thing I want to do is I want to figure out, just like we did before with this 12-month difference, I want to figure out what the most recent 6-month date range is. So we're going to take the newest video and we're going to go back 6 months just like we did before. We're going to use this exact same 12-month code as we did before, and we're going to take the most recent video and go back 12 months. And for every video that we have, we're just going to compare the most recent 6 months to the most recent 12 months. And then we're going to create this metric here, which is the aggregate of all of the medians. So we're just going to take the median of when this time period is in the past 6 months, and then we're going to take the median of all the values of when this time period is in the last 12 months. So let's just run this real quick so we can actually see the variables and put some addition. Okay, so let's just look at this so we can see what the dates are. So as you can see, we have the date timestamp of 6 months before. Remember, the most recent video was January 17th, and so I think it's July 17th would be the 6 months previous. That looks correct. And now this one, we can just see what the medians of all the values are for just that period, right? So this is what we're seeing, and that's what we're going to see on our dashboard here. These are all in line with what's there. Next, we're going to use the individual metric counts. So for us, let's just create a single metric, and that would be st.streamlit metric. And what we feed into this is first the label. So let's just do metric medians 6 months, and then we want to include, let's say, views, right? So the first thing we can do is we can essentially just do that. If we want, we can also include the values. So actually, we put the label here first, which would be views. So, and then the value would be that. So let's see what that looks like. Here we can clearly see that our metric of views is listed. If we wanted to add something additional, right? So let's do the delta. We can just put that in, and that would be, here we go. It's the additional one. And we would say, let's say it's 500. So we can see when we rerun this, that it went up 500. And so we can format that as well. So as you can see in the other dashboard, or in the final dashboard, they're all percents. We can adjust that, and let's go through and look at some of the code of how I actually made all of the metrics. I did it programmatically. I didn't do it just by going through each and every one of them individually. So another cool aspect of Streamlit is columns. So what you can do with columns, and this is both metrics and columns are pretty new in one of the most recent versions of Streamlit, if I remember correctly. But what this does is it creates 5 columns in the Streamlit dashboard. So if I wrote to each one of those, they would be lined up in 5 different ways. That's how I was able to, again, organize all of these metrics in a row. If I didn't have the columns, all of the metrics would just run straight down, which we wouldn't want. We want them to be shown across. The next thing I did is I just wrote a little for loop that would go through all of these different columns in this list that I've created of the columns and put all of the metrics in. So here we're going to go through all of the different variables. And honestly, the with statement, I just kind of borrowed from some Stack Overflow code and looking through the documentation. I don't exactly know its function there, but this code did work, so I can't complain too much. I will include some information on with in the documents, but again, this shows that you don't necessarily have to understand exactly how everything works for it to be functional in your code. So what we're going to do is going to create the delta. So this is going to take, for this specific variable, let's take views. So it's going to take the views from the last 6 months, and we're going to take the difference between the views for the last 6 months and the last 12 months. Then we're going to divide it by the views from the last 12 months. So that will give us the percent change over time. Next, we're going to create the actual metric. We're going to round the variable to 1 decimal point. Otherwise, it would just be like really long. And then we're going to use the delta, and the delta is going to be formatted so it is a percent and only 2 decimal places, right? And so that delta, that percent change is what we're putting in here. Next, we're going to increment this count. So we continue to go through, and the reason I added this count logic is probably not the most elegant way to do this, is that way we're going to have 5 of these metrics in each row rather than 10 all the way across, and we only have 5 columns. So what I mean by that is we go through once and we make this row, it counts to 5. After 5, we start at the next row of columns and continue on there. So that's why we have 2 there. Again, not probably the most elegant, but let's see what it actually looks like in our new one. So as you can see, we've created this metrics list here. This all looks pretty good to me. Obviously, it doesn't look as good that the views, likes, subscribers, and shares are down. But it is nice to see that the average percentage viewed is up, the view duration is up, and some of these other metrics are up. So yeah. Okay, so what we're going to be doing next is we're going to be building that table. So we're going to be building this. This is relatively easy to do, but the color formatting took me a lot longer than I would have thought. And so I got to experiment with how to do that in pandas. I'm going to show you what I did, but remember, this is something that took me a lot of time to figure out, a lot of Googling, a lot of Stack Overflow. So let's get started. So if we want to actually just add the data frame in, it's going to be really, really easy. So let's just like trim a little bit of the data here. So I do want this to be in a date format instead of, well, actually, let's just comment that out for now. So we're just going to do this df_ag differential final, which is going to take the aggregated difference that we had before and just only use a specific number of columns. So we don't want all of the data, it would be too long. We just want a couple of the different columns. So let's just see what this looks like. Oops. Oh, it looks like I have to add this in. Okay, there we go. And let's just look at what this looks like. So as you can see here, we just have a couple of the video titles and all of the different rows. From here, we can just do st dataframe and do our df ag div final. Let's see what it looks like. Okay, and now we can see that we have all of this information. All right, so now we can see we have all of our data located here. What I adjusted with publish date before, it would show the format and date time, so there would be all the timestamps and stuff, which would be really messy. What we care about is the publish date, so all we did was just trim out all of the time information. And now we have all of the decimal percentage values for all of these metrics, right? But this looks pretty ugly. It doesn't tell us a whole lot. So now we just want to format all these values so they're more useful to me if I wanted to take a quick glance at how any of these individual videos did. So let's go through and figure out how to do that. All right, let's get started with styling this data frame. So I found an awesome resource for this, obviously in the pandas documentation, and it shows how you can essentially like create a styler. You can format a bunch of these things, and you can get these exactly how you want. So for example, in this one, they made it so that there are no decimal points. So they're able to format all the values. For us, I had to go through some other steps to get this done correctly, and I'll explain how I went about that. So one of the challenges that I had is that I didn't necessarily want to format all the columns, right? So if we look at the total data frame here, the first column is going to be, or the second column technically, is going to be the video title. So I can't format this with like a numerical format, right? If I wanted to remove decimal places for this, it would throw an error. So I had to think about how I would approach that and filter that out in some sense. One way that you can format specific things or format all of the different individual data points is with the apply map feature, and we can pass a function into that. So I defined a couple functions up here. So the first is style negative. So for the value, if it is less than 0, we will be able to pass something into it. And same here, if the value is greater than 0, we'll be able to pass in some style formatting into it. And you know, the interesting thing here is that we can also throw a try and except statement. And so this will only run the function if it does not throw an error. If it does throw an error, it'll just pass and it'll be like nothing happened. So this is maybe like a little bit of a janky way to get around the text columns versus the continuous columns. But again, this did work for me. So remember, we have the style negative and the style positive column. So what we can do here is we can just apply map, and then we'll pass our style negative. And then the props is the parameters that we can pass in, and we want to color these red. And let's see what that looks like. So we're going to save that, look at our data frame here. We will always rerun. And that didn't work at all. All right, well, that didn't work, and I figured out why very quickly. You have to style, and that should allow us to pass this color red into the style based on these conditions. So let's double check that again and see if we did any better. Moment of truth, and we did not. Okay, third time is the charm. I forgot a semicolon, very typical. Now it should work. And what we can see here is that all the negative values are red, right? So now we just want to make all the positive values green. And again, generally with visuals, you don't want to use red and green to be sensitive of colorblind people. In this case, the metrics have built-in red and green, so I thought it was okay. Also, there is clear trend directions. So if you are going to use red and green, if there's a clear negative value or clear positives, it's generally okay. Not necessarily to use other color schemes like blue and oranges. Now let's go here and let's now style the color for positive. And we're going to do, oops. And let's see if this works out for us. Sweet. Okay, so now we have positive and negatives. And the last thing we want to do is make these all into percents. And I'll be honest with you guys, this was probably the hardest part of this entire project. I'm going to make it look pretty easy with a couple lines of code. But again, this was so much harder than I thought it would be. So what we're going to do is we're going to format each of these columns individually. So we're just going to do this above here. And so what we're going to be doing, I need the dfag numeric list also. Okay, so what we're going to be doing is we're going to just get a list of the numeric columns. That's all this is. I will show you what this looks like right here. Can we see this in the frame? Yes. All right, this is just all the numeric columns that we have in here. We are going to create a new dictionary. And for each of these columns, we are just going to say, hey, this column in the dictionary has this format. So pretty straightforward. So if we look at this dictionary, we will see that there is this function format string in each of these, right? And now we just have to define one more function, or we have to just add to the format this dictionary. So we are going to format and pass this dictionary in. So this just takes for each of these individual columns, it passes this percentage format in. Again, I don't know why this was so difficult for me to figure out after looking at a lot of documentation, but this was the best, this is the best option that I came to. So as we come here, as we refresh, we can see that we hopefully now have percentages, and we do. Beautiful. So now I can look and I can say, wow, like this How I Would Learn Data Science video performed really well across all of these categories. As I described before, the engagement ratio on those is going to be pretty far off, or views versus subs gained. You know, a video, for example, why everyone should start a podcast, including you, like one of my favorite videos to make, but just absolutely brutalized in terms of the numbers associated with that. Maybe it was a little bit off brand, who knows? But again, this is a really useful high level look at what videos really hit and which ones didn't. Now let's shift over to our individual video metrics. Okay, let's start with the individual video analysis. So as we recall, what this is going to look like is we're going to have a drop down up here for the video, for the specific video. And we're next going to have this little bar chart here that shows how many people who were subscribers that watched versus not subscribers, and the proportion from the various countries that are popular in my YouTube audience. So the US and India are two of the biggest audiences that I have, and then the other are all effectively around the same proportion. So this is actually broken up by each individual country. And as you can see, the next biggest one in comparison is maybe half the size at best. Next, we're going to build this line chart here that shows the video popularity in terms of views in the first 30 days that were published. The first thing that we do have to make, though, is this little drop down. So let's try to build a drop down, and I'll show you how that works. So let's go to our other data here. So right in here, obviously we were able to show end on the screen, which is good, but we actually have to make a little bit of a different drop-down sidebar here. Well, this isn't a sidebar, it's just a video selection box. So we're gonna call this video select, so that's what we're gonna do with it. And we're gonna create a select box, so st, and we want it to say, to be titled or have next to it is like what the text is, pick a video. And in order for this to work, we have to include a tuple of all the different videos we want to look through. So maybe it would be video 1, video 2, etc. So let's just see if we can get that to show up on the screen. That is not the newest version. This is the one we want. So let's refresh it. All right, and we'll go to the individual video analysis so we can see video 1 and video 2. This isn't going to be all that useful to us, but this does show how this actually works. So we're going to want to get the list of all of our videos in here instead. And one of the challenges is that we have to put it in that tuple format, right? So a tuple is an uniterable, you can think of it as an uniterable list. So if we have a list, we can convert it into a tuple relatively easily, and that's exactly what we're going to do here. So first, we're just going to get our videos. Oops. And we're going to use the tuple keyword, and we're just going to take all the video titles and, turn that again into a tuple. So what that looks like here is that now they're all in parentheses, basically. And instead of this, we're going to use the videos variable that we just created. So now let's see what this looks like. Oops, keep going to the wrong one. And now you can see all of the videos are there in the correct order. All right, now let's create the little bar chart. So the first thing we want to do is we just want to filter our data based on the variable that was selected. So whenever we choose a specific video, the video select variable will be, we assigned the string that we select. So if we select, let's just take a random one. Should you be excited about Web3? As a data scientist, you will get a string of that. And we can filter the video title based on that. So if we choose the Web3 video that I described, we will only get data for the Web3 video by writing this line of code here. Next, we want to do a couple of these things. We have both the ag filter data, but in this case, we're going to want to use the other data frame that we loaded in that has the subscriber count as well as if people are subscribers or what country they're from as well. And so we're going to use this df ag sub data frame, and the same video title column is in there as well. So we can use this and filter this data in the exact same way. The next thing that we're going to want to do here is look at country, and we are going to filter this by a new function that we create. And that function is just basically going to split things into US, India, or other. So in this case, since these are, again, the largest audiences, I think it's easier visually just to compartmentalize them in US and India. Obviously, every other country and all of the people that watch my content from around the world are just as important. It's just for this use case, these are the three biggest categories that I thought were most easy to digest visually. So when we use apply, we can just pass the function in, which is the function we just described. It is a very simple if, elif, and else, where if the country code is US, it returns USA. If it's India, it returns India. And if it's anything else, it returns other. So that makes it so we can create these other groups really easily. And then all we're doing here is we're just sorting all the values by if people are subscribed or not. I did this because when I created the graph the first couple times, it would flip-flop on the visual which was on top. So sometimes true would be up here, sometimes true would be down here. And I don't think that's generally a good practice. So I just switched that around a little bit. Now, all we have to do is build the graph. And for the first graph, we're going to use Plotly Express, which I think is really easy. And you're going to be like, wow, this was unbelievably easy for you to create that. So what we do is we just define a figure. In this case, we're going to use Plotly Express. We're going to use the bar chart. We're going to pass in the data. And in this case, we can pass in the column names and it'll create the chart itself. So on the x-axis, it's going to be the views. On the y, we're going to have two columns. One is going to be is subscribed is equal to true. The other is going to be is subscribed equal to false. And the color is going to be the country that I just defined here. And we want this to be a horizontal bar chart. So we're going to orient it as H. And if we save this, we can see what this looks like now. I just have to always rerun. And on the individual analysis, we should be able to, oh, no, sorry about that. I have to actually pass the figure into Streamlit. So in order for this to show up on Streamlit, we just have to do this. So we just do fig. So we've defined this figure. We pass the figure into Streamlit Plotly, and then now it will show up. And Streamlit has compatibility with basically every visualization tool that I've used in Python, which is unbelievable. Again, I usually don't get it right on the first try, but I eventually get it right. So now, oh my goodness, there we go, it worked. So let's check out a couple different videos. So maybe we need to talk about the machine learning assessment. You know, a lot of things are very popular with my audience, whereas there's some other videos like, let's say, is data science dying, where the vast majority is viewed by non-subscribers. So I think this is pretty interesting, is understanding which videos appeal to different audiences. So maybe my, let's see, how I learned to learn video. This one's a pretty good balance. That to me is a little bit different. Let's see another popular video. So how data science projects pay off. This is a very Ken audience related metric. So I'd probably love to be able to figure out what types of videos focus more on the is not subscribed market as well, or have more of that balance like the learn to learn video. Okay, so we're now on to the last part of the dashboard, which is where we want to create that time series graph that shows how our video is comparing against the 50th percentile, the 20th percentile, and the 80th percentile, all in the first 30 days. So there's a couple steps that we need to take to be able to organize this data in the appropriate way. So the first thing is we have to look at the time series data itself. And something we'll find in this time series data is that there's a date, which is literally every day, but we don't have information on when the date that the video is published. So in order to get the number of days that a video has been out, we have to subtract the current date of the data frame minus the time that the video was published. So we have to join two data frames together. So let's just real quickly post some code in. So we're going to merge the time data with just some small subset of the aggregated data. So what we're going to get is, again, like this time series data frame with just, we're going to join on the video name, or like, I guess it's the video ID, and include the video publish time. So eventually we'll just take the video publish time, the date minus the video publish time, and we'll get the number of days that includes. And that's exactly what we do right here. So the number of days since the video is published is the current date minus the video publish time, and then we convert this into days. That is what the date time days does there. Now the next thing we're going to do is we're going to create a 12-month moving window, just like we did before. So what is 12 months since the previous maximum? We've done this with everything. That's the baseline we want to compare things against. That's how we're going to make our medians. We don't want to do medians from all time because those would be low. It'd make it look like every video is doing really well, which unfortunately isn't always the case. And now we're just going to create this data frame where we're only using these 12-month moving windows. Next, we're going to create a pivot table. I prefer pivot tables over group by, that just says for each day in the first 30, what how many views does a video get on average. We're also going to create some aggregation functions. So we're going to have the mean, the median. This is going to create the 80th percentile, and this is going to create the 20th percentile. And in theory, median should also be 50th percentile. So let's just run this and see what it looks like. And then print it here. So some videos, they have negatives for days published, and that's because sometimes I publish the videos unlisted. I'm assuming that's why, and I edit them and then I release them and I watch them a couple times. So this isn't crazy uncommon. You have to do that for sponsors a lot of the time. They want to make sure the documentation is right. And as you can see, all the views and the relevant metrics are very, very negligible. This also goes up to around a year since the video has been published, just like we'd expect from this month offset. So what we're going to do is we're just going to trim the data here. So we're going to take we're going to rename the columns of this first because they're double labeled, which we don't want. And then we are going to only take the days that are between 0 and 30, and this between is inclusive. So I guess it's technically 31 days, right? Or maybe even 32. But now if we look at this, our data only includes the first 30 days that every single video is out there. So we have 0 to 30. Probably have to reset the index, but that's not the end of the world. So the next thing that we want to do here is we want to get the cumulative of all of these rather than having the non-cumulative. So we want to see not just how many are additional each day, we want to see the running total of each day. And we do this by getting views. We're just going to use the cum sum or the cum sum, right? We're going to use the cum sum. And just like we've done before, we're only going to do it on the numeric columns. In this case, there's few enough where we can only include these specific ones. So we care about median, 80th percent, and 20th percentile. So we can just run this and let's see what it looks like. Oops. Cool. So if we look at views cumulative now, we see that these numbers continue to go up, which is what we want to see. And these all look relatively correct to me. All right, now we can start building our last chart here. So the last chart that we're going to build again is that line chart, and we're going to use Plotly again. It's just going to be a little bit different here. So we're going to use Plotly graph objects instead of Plotly Express. Okay, so we filtered for the first 30 days above just to get the median, 80th percentile, and 20th percentile values. But we also have to filter for just the first 30 days for all of the videos that we've created, or all of the videos in this data set, right? So we're going to go through and choose all the data for each individual video. We're going to create this first 30 data frame, which filters for days published between 0 and 30. And then we're going to sort the values so that they're in order from lowest to highest. Next, we're going to go in and build our figures. So this is going to be fig 2, and we're going to do go figure. So this creates a Plotly graph objects figure. Next, in this case, we're going to add an individual line to it. So This works a little bit differently. So rather than us feeding in all the data and the back end of Plotly Express formatting it for us, we're going to have to add each individual line into this data frame, right? So the first line we're going to add in is the 20th percentile line. And so the type of chart we're going to use is a scatter chart, but the mode we're going to use is line. So it's going to connect all the dots. So the X value here is going to be the views cumulative days published, which would be this. And the Y value is going to be the views cumulative 20th percentile views. Down here, we have the name of the line for the legend. Right here is our details for the line. So for each line, we can pass in a dictionary and we can add attributes to the line. So this one is going to be purple and this one is going to be dashed. So let's just see what this looks like. We'll do Fig 2, Plotly, not quite. And let us see how. All right, so now we can see that there's this 20th percentile line, right? As we can see, it goes up, after 30 days, the 20th percentile video is looking at around 2,794 likes. So now let's add the other ones in and eventually our new video. So we're just gonna add 2 more traces. So this one is going to be, again, same days published. This one is going to be the median views, which is 50th percentile. We're going to show it as a line. So if we didn't want, maybe we could do like lines plus markers. And I'll show you what that looks like in comparison. The name is 50th percentile. We're using black as the color. We're also using dashes again. And then for 80th percentile, we're using blue with dashes again. So let's see what this looks like. Oops. All right, so in this case, you can see where I added what it looks like to have lines and markers. That's something I'm obviously going to remove, but it just shows you how customizable this is, which is pretty neat. The last thing we're going to do is add our actual line, which will again be relatively easy. So let's remove our markers here as a little example. And we will now add in our last line. So this one is going to be from the different data frame, which is the first 30 that we've created up here. It's be the same days published. We're also going to be using views and the cumulative sum of the views here. So we could have done it up here. I thought it was fine to just do it down here instead. We're going to call this the current video. And in this case, what we're going to change with the line is we're going to make it fire brick, which I think is a pretty sick color. And we're going to make it a lot of a wider line. So let's do that. And then now when I reload it, we should be able to see how the video is trending. And, in the real world, I would make this live, and I might actually make it live with my data. I just have to upload it to a database pretty frequently. But that would be what would be relevant for an individual creator. So I could look at the last 2 and say, okay, how did this one do? Oh, it's not doing that well. Is there something actionable I could do to make an adjustment to this in somewhat real time? And this one, the only data explanation you need, is doing pretty well in this period of time. Definitely check that one out if you're looking for a good high-level explanation of data science. The last thing we're going to do is we're just going to format this a little bit nicer. So we're going to add in just some formatting. So we're going to update the layout. We're going to add a title, and we're going to say view comparison for 30 days. The x-axis is going to be days since published, and the y-axis is going to be cumulative views. So let's see what that looks like now. Apologize, I have to keep flipping back and forth. But there we go. So now we have the view comparison, cumulative views, and days published since. So again, this is a pretty straightforward dashboard that conveys a lot of information to me as a creator. Obviously, this is something you could 100% expand upon. I did virtually no formatting of the graphs. I mean, you could make this a clearer background. You could add different columns for the graphs. You could make these more relevant colors. I don't know too many places where the USA is depicted as green, you know. India, the color probably isn't like way off, but we could do a lot better. You know, something like this we could expand upon. If we're looking at the aggregate metrics, we could make these into a more visual rather than tabular format. And there's so many things that have still completely gone untouched. I really want to commend everyone who's worked on the data in Kaggle that I've put out there. Just looking through those, you can find some really incredible visuals that you could integrate here. One thing I would really recommend is exploring the comment data and perhaps making like a frequently asked question type of thing. That to me is something that I would like to integrate into a dashboard like this next. So again, I mean, there's plenty of opportunities to make this your own, to expand upon this. There's also themes in Streamlit, so you could make it like a dark theme or spice this up in terms of a color palette quite a bit as well. You know, this is just scratching the surface of what is possible. And to be perfectly honest, Streamlit, the Streamlit part of this, the dashboard building part of it, was the easiest part of the whole process. Like formatting this table in pandas was harder than the Streamlit stuff. Like making sure I was creating the baselines was more difficult. So to me, it's so cool that you can create just like awesome interactive like web platforms while not having to do too much complicated work. Right, you can take the graphs that you've built somewhere else or that you've already worked really hard on and make them into something that's very visual and interactive almost instantaneously. So the last thing we're going to do is show you how to put this online and make this public to everyone. This is important, especially if you're sharing it within your portfolio. Okay, so in order to get this online, we're going to have a GitHub account, which is pretty easy to set up. My GitHub is playing numbers, which you'll see I've done, I'm not super active on, but I'm active enough. What we need to do is to create a repo for this specific dashboard project. So the easiest way to do this would be to just create a new repo and upload it. We can also use git bash from the computer. There's plenty of different ways to access GitHub. I'm going to do the really lazy way and create a new repo here. We're going to call this YouTube dashboard st, and we're going to make it public. We're going to add a README, and we don't need a license. So right now we have this YouTube dashboard here. I'm going to go in, I'll fill in the README later, but I'm going to add some files. I'm going to upload some files. So I can choose files, and we'll just go to our dashboard here. Let me make sure I save our dashboard. All right, it is saved. We're going to take all of these and we're just going to put them in here. We do have to add one additional file, which is the requirements file. And that's what lets Streamlit know all of the libraries that we're using and what versions they're in. So we're going to go into our Anaconda prompt here. And so we're in our YouTube dashboard environment that we created. And so all we're going to do is we're going to type pip freeze. And I'll show you what that actually does. So pip freeze, it creates a list of all of the libraries that are installed in your environment, right? So we're gonna do pip freeze, and we're gonna do a caret that way, and this, and type require. So this is gonna put all of those into this requirements.txt file. And so now you will see this requirements file here, and we're going to add just this last one. Okay, so we uploaded the requirements.txt file. I went through and I had to comment out just a couple things. There's a few things like that are related to Windows. So I commented out pywin32, pywin32 C types, and pywin whatever that is. Those aren't relevant. Those are only relevant because I'm on a Windows machine. So it should work after I eliminate those things. So now let's go and create a new app. There we go. We're going to be doing Ken dashboard. We want this to be Python version 3.8 because that's the version we're going to be that we installed on our computer, and then we will deploy and hopefully it will work out for us. And now we wait. All right, so now our Streamlit app is live. We can click around, we can look at all the different videos, how they're trending, and I will post the link to this in the description for you to check out. Also, all the code will be available. I'm gonna go ahead and clean the code up, add some comments, make it actually legible rather than the chicken scratch that it is now. But hopefully this was useful in first helping you understand what goes into a project, second helping you understand what goes into a dashboard, and third giving you a place to start from that you can build on. Obviously this is in the really early stages. There's so many different things you could improve upon with this dashboard, and I'd love to see what you guys do. You know, if you build a dashboard related to this data and you share it with me, I'm happy to forward it along. Hopefully that'll help you create some more job opportunities for yourself or help you to build out your portfolio. As usual, thank you so much for watching and good luck on your data science journey.